Good morning, good afternoon, good evening. Welcome back to chapter 15. We're talking about the major events in the history of the life of the planet. We made it up to the Cenozoic. Remember, the Earth is divided into 4 unequal periods: the Precambrian, the Paleozoic, the Mesozoic, and the Cenozoic. The Mesozoic is where we find dinosaurs! After the dinosaurs were wiped out by the really big rock, the asteroid, we now enter what's called the Cenozoic. The Cenozoic started 65 million years ago. Cenozoic stands for current animal. Once all the dinosaurs were wiped out, there was a bunch of jobs that weren't being done now. Mammals, birds, and pollinating insects had a huge adaptive radiation to fill in all of these jobs that weren't being done. Angiosperms, flowering plants, suddenly did very well. Massive speciation of flowering plants of angiosperms. Again, 65 million years ago is when the dinosaurs died. When do we first see the first humans? Well, 2 million years ago, we see our first ape-like hominids. We see our first human-like apes. About 200,000 years ago, we see our first actual humans. And then about 30,000 years ago, we see modern humans, us, 30,000 years. Again, put those dates together. When did humans first show up? Maybe a million-ish years ago, 2 million years ago. You can say things that are close to being humans show up. When did dinosaurs die? Dinosaurs died 65 million years ago. Did cavemen ever run and hide in a cave from dinosaurs? Nope. Cavemen never saw dinosaurs. Humans and dinosaurs never lived together. Dinosaurs had been gone for 65 million years before humans showed up. Mass extinctions affect biological diversity terribly. The current extinction rate is 100 to 1,000 times faster than normal extinction rates. We're currently in the middle of a mass extinction, and I'm not talking about the virus. We've been in the middle of this mass extinction for about the last 100 years, really since the Industrial Revolution. We're pretty sure it's our fault. At least, at best, our actions aren't helping the situation. At worst, our actions are creating the situation. What we're doing to the environment, what we're doing to ecosystems, we're pushing plants and animals to extinction at a very, very fast rate. There are 3 groups of mammals. Remember, mammals didn't really get their start, didn't really get their chance until dinosaurs died. Dinosaurs died about 65 million years ago. There weren't very many species. Until when? Until the dinosaurs died. When the dinosaurs died, we had a huge expansion of placental mammals. Quite a number of marsupials also started to do really well once they didn't have to compete with dinosaurs anymore. And there haven't been very many monotremes. The different groups are egg-laying mammals, pouch mammals, placental mammals like you and I. 5,000 species of placentals, about 300 species of marsupials, only 5 species of monotremes. When did they start to have their gigantic radiation? When there start to be a whole bunch of them? That 65 million year mark. That's when they started to branch out. Adaptive radiation. Radiating adaptively out into new environments that were no longer occupied by dinosaurs. How does one population change into multiple species? One way is not by necessarily changing the genes, but that is a very important way, is new genes or changing the genes. One way can simply by changing when genes get turned on and turned off. When we turn on or off these developmental genes, that can greatly impact what the end result is. You turn on a gene earlier, it has a bigger impact on what it's on the outcome of the individual. You turn a gene off sooner, has a big impact on what the adult form is. How long these developmental genes are on, dramatically impact the end result, the adult. When they get turned on, how long they're turned on, when they're turned off, has a big impact. Pedomorphosis. Pedo means child. What does morph mean? It does not mean change. Morph means shape. The process of child shape. Pedomorphosis is retention of juvenile characteristics in the adult, or when a juvenile becomes sexually active without taking on the adult form. And well, those two things are slightly different, but we'll just lump them together. Retention of juvenile features in the adult body. This is an example of a pedomorphic individual. This is a salamander. It's not a lizard. This is a salamander. And what do I want you to see? What I want you to notice is these structures right here. Those are the gills of this salamander. Now remember, a salamander is an amphibian. Amphibians are born in water and come out on land as an adult. Well, do gills work on land? If they did, fish wouldn't die when you brought them out of the water. Gills don't work on land. So a salamander that comes out to live on land is not going to have gills. This is an adult salamander that has gills. That is pedomorphosis. Gills are a juvenile characteristic for salamanders. This is an adult that retains juvenile characteristics. It actually helps this salamander because it spends its whole life in water. It actually doesn't come out of water. So changing developmental genes, not turning off the gill gene, changes the species that this population is. This is another really, really powerful graphic. We see the skulls of a chimpanzee infant and the skull of a human infant. And to be fair, if I didn't tell you that this was the skull of a chimpanzee infant and I said, that is a human skull, that is a baby skull, you'd say, okay. Notice how the skulls of the human infant and the chimpanzee infant are very similar. The squares contain a piece of bone, and this graphic over here shows how each of those sections of bone change developmentally as we go from a baby face to an adult face. And we see, look how much the jaw changes on the baby when it converts into the adult. Look at how much this box is distorted and this box is distorted, and look how little those boxes change. All right, this shows the distortion of the bones as we go from a infant face to an adult face. Now look at the human. Same basic construction as the chimpanzee face. See how little the human face is distorted relative to the adult human versus the chimpanzee adult? We have what's called a pedomorphic face. Humans have a flat face. We have a baby face compared to most other mammals. This baby face, why do babies have flat faces? Why are babies cute? Why are baby cats cute? Why are baby dogs cute? Why are baby anything cute? One of the reasons why baby mammals are cute is because they have flat faces. That flat face is a juvenile characteristic. We're kind of pre-programmed to see that flat face and go, oh, it's cute. The reason why baby mammals have flat faces is because it makes it easier for the infant to nurse. If they've got this big jaw, if they've got this big nose, it's hard to latch onto the nipple. It's hard for the baby to nurse. Having a flat face makes it easier for the baby to nurse.